row by column. You should have gotten the identity. Now, if you want, we can do that very quickly together. I hear mixed things. Some people want to, some people don't. So, don't worry about that little word in the middle. Let's do it together really fastly. So I said fastly. Okay. Actually, you can write on this for me today? Come on. Okay. Here we go. First row, first column. 0, minus 1, plus 2, plus 0, positive 1. First row, second column. 0, minus 4, plus 4, minus 0, or plus 0 is 0. Negative 1, minus 1 is negative 2, plus 2 is 0, plus 0 is 0. Negative 1, minus 3 is negative 4, plus 4 is 0, plus 0 is 0. I'll just do the next row and we'll call it down from there. 0 plus 1 is 1. Where am I? Okay. Minus 1 is 0, plus 0 is 0. 0 plus 4 is 4, minus 2 is 2, minus 1 is 1. 0 plus 1, minus 1 is 0, plus 0 is 0. 0 plus 3, minus 2 is 1, minus 1 is 0. Good. You can see the diagonal matrix forming here. You should have gotten 1, 1, 1, 1, and everything else is 0. Thank you. That, what she is drawing right now, is called the identity matrix. The identity matrix is a matrix. It has to be a square. An identity matrix is where you have 1 perfectly along the diagonal and zeros everywhere else. Now, the identity is I should be recording this. I am recording this. The identity is something we've been doing since we were in grade school. Back in whatever grade you learned how to do 2 plus 0, 0 was the identity because you added something to it and you got 2 right back. What's the identity for multiplication? What can you multiply by something and get the same thing? 1. When it comes to matrix multiplication, this is an identity matrix. Now it can change in size depending on the 2 by 2, 3 by 3, 4 by 4, whatever. But any matrix that you multiply by this, you'll get the exact same thing back. Hence why it's called the identity matrix. Now I could multiply this by this to show that to you, but I promise you get the exact same thing back, so let's not worry about it. Now, why is this relevant? When you multiply 2 matrices together and get the identity, well, let's think about when we did that in the past. You take 3 1/3, multiplying, you get 1. You take 5 1/5, negative 4, negative 1/4. Anything you can multiply to get positive 1, we call the multiplicative inverse. And matrices, any 2 that you can multiply by each other and get the identity, they are multiplicative inverses of each other. These matrices are inverses of one another. Because when you multiply them, you get the identity. What we're going to be doing today is we're going to be finding the inverse of a matrix once we already have the original. And then we're going to check and make sure it's the inverse by multiplying them and making sure we get the identity.
So we're going to be dividing?
No. When did I say the word divided?
Because if you multiply them, you get the identity. You have to divide them by the identity.
No. I see what you're thinking. But no, that's not what we're going to be doing. I'm going to show you a method for finding the inverse. Okay. Here we go. First slide. Find the products. Okay, all you have to do on this slide is a bunch of multiplication. That's why we started with it. You multiply. If you get the identity, then they're inverses. It just says find the products to determine whether they're the inverses of one another. One thing is you should get the inverse in both directions. You should get it in both directions. If you don't, then they're not inverses. AB and BA.
So
order matters.
right,
So like
on number 1,
A times B and then B times A in both of them. What?
So like, what you're saying is like, if you were to multiply A times B, you get 1, 0, 0, 1.
That's exactly right.
And when you do BA, you get 1, 0, 0, 1.
That's right. Here we go. Let's see if we can do that. 4 times 4 is 16. Negative 3 times 5 is negative 15. 16 minus 15, 1. 12 minus 12, 0. Negative 20 plus 20, 0. Negative 15 plus 16, that's 1. You have to try it in both directions. Now we're going to do B. That's right. Now we're going to do BA. So this row, this column. 16 minus 15, row, column. Negative 12 plus 12, next row. 20 minus 20, negative 15 plus 16, and they are. If you get the identity, then they're inverses. Now let's say number, what is this? I guess it was supposed to be 11. Number 11, you start working on it. Your product's going to be a 4 by 4. Let's say, it probably won't work out quite this nicely for you. Let's say the first number you get, what is happening? First number you get is a 2. Is there a 2 in the identity matrix? You can stop right there and say not inverses. As soon as you get something that does not fit in the identity, just stop and say no, they're not inverses. Questions? All right. Just multiplying, just like yesterday. That's what we just did. Okay. 2 by 2s. Finding the inverse of a 2 by 2 is a very simple little procedure. You probably want to copy this down. Right here. Write this down. Right. It's a formula, basically, yeah. Yes. Write this down and then this. In fact, I'll highlight the portions you need to write down in your notes. That one and that one. That's what you need to get down in your notes. 4. It's a 4. We only have one more section that we're going to cover. Then we're going to be done. Yeah, we're going to do something. No.
That means you're left off.
No. We'll just do some review on Friday. We'll review on Monday, and plan on your test day next Tuesday. I don't know. It just works. Actually, this goes back to what I was saying to Hannah. Remember yesterday Hannah was talking about how she cried this weekend, and I said when I was in college I had to do a ridiculously long problem. I essentially had to find this, but it was of a 4 by 4, and it was brutal. So 2 by 2 is the only one we have this kind of formula for. It's a question. Now, what does this say? This simply says we're going to find the inverse using this formula. We are then going to check and make sure it's correct. Because we're going to take our original, multiply it by the inverse. That's what this means, A inverse. And we should get the identity. This 2 just means a second ordered identity, which all these are going to be. So, given that we start with some random A, B, C, D, the inverse of a matrix is simply you switch these two numbers and you change the signs on these two. That's what this says. So for this one, switch these two, which are still going to be 2 and 2. Change the signs on these two, -3, +1. And out front, you take 1 divided by, this is called the determinant. AD minus BC is called the determinant. AD is 4 minus BC, which is -3. 4 minus -3 is 7, so 1 divided by the determinant. And this is our inverse. Now you can distribute the 1/7 if you want to. 2/7, -3/7, 1/7, and 2/7, but you don't have to. That's it. That's the inverse. To check it, which I'm not going to require you to show, but it's important you need to know how to do it because on the next test you'll be able to see which answer is right if you just know how to check it and see if it's right. To check it, you multiply it in both directions. So first, A times A inverse. I I like to leave out this little scalar rather than multiply it through because you can do it last and it's easier. So I'm going to save the 1/7 for last. A times I inverse. 2 times 2 is 4, plus 3 times 1 is 7. 2 times -3 is -6, plus 6 is 0. -2 plus 2, 0. Positive 3 plus 4, 7. Now remember, I still have, yikes, okay. I still have that 1/7 sitting out here. Exactly. Okay, this is fighting me, but you can see, when I multiply through by the 1/7, I'm going to get 1001. Yay, the identity. And that's what you should get if you did it correctly. Yes. Then you have to go the other direction. Although I've never seen one work for one and not the other, so I wouldn't care if you didn't show that, but technically it is part of the rule. But doing it in the other direction, I'll do it just for this one. No. All I really want is the inverse. You just need to know how to check it for future reference. So multiply them. We still have the scalar out here of 1/7. So that's 4 plus 3, 6 minus 6, 2 minus 2, 3 plus 4. And sure enough, when you multiply 3 by 1/7, you're still going to get 1001, which is the identity. Questions? All right. Okay. We are now going to find the inverse of a 3 by 3. Inverse of a 3 by 3. Now, there is no formula for the inverse of a 3 by 3. You're going to have to go back and do that same matrix step we were doing before, but slightly different. This is how you find the matrix of a 3 by 3. Let's look at number 21. 21. Actually, you can do this for any square matrix. It could be a 2 by 2, 3 by 3, 4 by 4. 21. I'm going to rewrite down that matrix. Then you put a little partition and put the identity on the other side. We are going to do the exact same thing we did last section, I know, grown, when we were solving systems of equations, but the difference is instead of then doing it to the answer column, we are going to do it to the other side of the matrix as well. I need to get the left-hand side to be the identity. That's the goal. Just like in the last 2 sections ago, I need to get the left-hand side to be the identity. What do I need to do to the top row to get it to cancel the bottom 2 rows? Very good. And then just negative R1. Now you have to do it all the way across your matrix. So we're not changing the top row for now. That's right. When you're done, once you've solved the identity, what's on the other side is your inverse. So that would be 2, 4, -2, 2, 0, 0. Add that all the way across, and you get 0, 4, -1, 2, 1, 0. Negative R1 will be -1, -2, +1, -1, 0, 0. Adding that to the bottom row, you get 0, -3, 1, -1, 0, 1. No, I have to get the entire identity. Now, back what I was saying the other day, the reason I taught you the first method is because looking at what we have to work with, in my opinion, the easiest step from here would be to jump down to this and just add it to the other 2 rows, and that would wipe out that column. That's why I taught you guys that method. If we do the book method and then divide the middle row by 4 and get rid of this, that's fine, but it's going to make this other step a little harder. I don't care how you do it, but I'm going to revert back to the first way that I taught you. You don't have to if you don't want to. I'm going to take the third row to knock out the third column because that would take the least amount of algebra at this point. I'm going to take row 3 plus R2 and row 3 plus R1. You should already know how to do this your own method anyway. That's what we've spent 3 days on. So I don't care how you do it as long as you get it done. Third row doesn't change. 0, -3, 1, -1, 0, 1. All right, adding that to the second row, you get 0, 1. Ooh, that looks nicer. 0. Let's see. 1, 1, 1. Adding the bottom row to the top row, you get 1, -1, 0, 0, 0, 1. Another perk to doing it like this is now the second column's looking much prettier. Instead of having to divide by 4, we can just take the second row, add it to the first row, and multiply it by 3 and add it to the third row. So, again, one reason why I preferred this method. So our next batch of steps is going to be row 2 plus row 1 and 3 row 2 plus row 3. That's what we're going to do. The only one that's not changing is the second. Whoa, that's hideous. Is the second row. That's going to be 0, 1, 0, 1, 1, 1. Adding that to the top row just as it is. 1, 0, 0, 1, 1, 2. I added these two rows right here. 3 row 2 plus R3. I'll write 3 row 2 down here. That's going to be 0, 3, 0, 3, 3, 3. Add that to the bottom row. You get 0, 0, 1. As you can see, we're done. 2, 3, 4. The right-hand side is the inverse. You have found the inverse of this 3 by 3. That's the only way to do that. That's true. The good thing is you're going to have to find the inverse. And if you're sitting there thinking, well, who cares about the stupid inverse? How does that help us? I'll tell you how that helps you. If you did not like solving those systems of equations the other way, there's another way to solve 4 by 4 systems of equations. And that is, let me ask you this. If I gave you the equation 3x equals 6, how would you solve for x? You divide by 3 or multiply it by 1/3, right? You would multiply both sides by what? The inverse of 3. Same thing here. Remember, every matrix represents a system of equations, right? So let's say this 3 by 3 we had actually written out as a system. What you can do is find the inverse using this method, and then same way as you multiply 3 by 1/3 to cancel it out. If you have, in fact, let me just jump straight ahead to that slide. Something like this. Now, on these, they're going to give it to you. This is this matrix right here. Now, they're providing you the inverses to save you a step. But if you take your matrix, find its inverse, which they provided for you, they thank you as well, and then multiply the inverse by the solution, it'll solve the system right there. So that's one more way to solve these systems of equations. So on these, all you have to do is take the inverse that they've provided for you, but in the future, yes, you're going to have to find it yourself, and just multiply it by the answers. And it's frozen. That's awesome. So let's just look straight at a hard one. Let's look at 41. Actually, I don't need to do that. I'll just scoot over. 41. I'm going to multiply my answers, my inverse of my original function, 0, -1, -1, 1, 4, 1, 3, 1, 2, 1, 2, 0, -1, 0, -1. I'm going to multiply that by my answer column, -3, 4, 2, 4. Thank you. That will give me W, X, Y, and Z. We will have solved that system of equations. Observe. And this is all you have to do with these later too. Take the inverse it provides you, multiply by the answer, boom, solve. Okay. 0 plus 0. Oh, I should mention, we're going to have a 4 by 1 over here. 0 plus 0 minus 2 plus 4 is positive 2. Negative 3 plus 16 is 13. Plus 2 is 15. Minus 12, 3. Go to the next one. Negative 3 plus 8 is 5. Plus 2 is 7. Minus 8, negative 1. 0 minus 4 plus 0 plus 4, 0. Boom. You solve a system of equations. That 4 by 4. You found the inverse. Well, you still have to find the inverse. So technically there is still some of that math to be done. But some people might think that's the easier way. It's extremely similar, actually. Extremely similar. That's true. And the one downside of doing it like this is if you did not check your inverse when you were done, now these they gave it, so we didn't have to check it. But how do we know we're right? We'd have to multiply it, make sure we got the identity. And if this was wrong, it'd be the same boat as you were before. You'd have to find your error. So they both have their pros and cons. But that's how all this is tied into each other. You can solve these systems by finding the inverse, multiplying it by the answers. So you're going to have, I think, 2 or 3 of these later. Inverse, all you have to do is take the inverse they provided, multiply it by your answers, just as they are. And that will give you the solutions to the system. Okay. No, that was the old method. This method, you leave it out until the end. Yeah. All right, we're pretty much done. Only thing we have left to do. Oh, do y'all want to do one more of actually finding the inverse? Sure. You mean doing a 2 by 2 this method? Because yeah, I can. You want me to do it like they did it, or do it the way I just showed you guys? Okay. You don't have to. No. Finding an inverse of of any matrix will work like that. Actually, it can only be a square. Oh, come on. Will work like. Okay. I'm gonna have to take this elsewhere because the bottom half of my board stinks. All right. So we're gonna find the inverse. Doing it this method. What do I need to multiply the top row by to get a 1 there? To get a 1 right here, what do I need to multiply this row by? 1/10. So that'll give me 1, negative 2 over 10, which is negative 1/5. 1/10, 0. Okay, so here we go. What do I need to multiply the top row by to get rid of the one below it? 5. 5 row 1 plus row 2. Writing that below it, that's going to be 5, negative 1. Let's see, 1/2, 0. Adding that to the bottom. Why did I? What do you mean? Did it simplify? What? Oh, that's true. I could have. Okay, now look at what we have here. Look at what we have here. Is it possible for us to get the identity for this one? Why not? There's no way to make that a 1. You're right. This one doesn't have an inverse. Is there a faster way to know if your matrix isn't going to have an inverse? I'm glad you asked. Yes, there is. Remember what I said, the determinant, AD and minus BC? Your determinant is called that because it helps you determine whether it has an inverse. AD is 10, minus BC is also 10. If your determinant is AD minus BC. If your determinant is 0, then you're not going to have an inverse, which should make you happy. It means you don't have any more work to do for that problem. If your determinant is 0, no inverse. Equals happy, that's true. And you can just write, no inverse. If your determinant is 0, remember for the 2 by 2, your determinant was this guy, AD minus BC. Well, here's the thing. You'll want to do a 2 by 2. I was just doing that for an example of how to do it the other way. Do a 2 by 2 the way I first showed you, because that makes you find the determinant anyway. And if you get 0, 1 divided by 0 is impossible anyway, so you can just know right then. But yeah. You shouldn't get any more. You shouldn't get any other impossible ones other than 2 by 2. Other than 2 by 2. Yes. Yeah. Yep. Inverse times the answers. Row, column, row, column, row, column, row, column. All right. Only other thing you have to do today is, only other thing, and this is the easiest step of the day. Right here. All they want you to do is show that you can extract a matrix from this. And here's how you'd write this system as a matrix. 6, 5, 5, 4, 13, 10. And write your variables out here as the side. This is a matrix equation. That is number 29 written as a matrix. That's all you have to do. It's just getting you to notice, if I were to multiply this back through, I'd get 6x plus 5y equals 13. 5x plus 4y equals 10. Just by matrix multiplication. The ability to do that is how you get to be able to do this slide. That's the reasoning behind it. Okay, 31, 1, 3, 4, 1, 2, 3, x, y, z. Okay. Here you're doing just the opposite. They're saying here's the system, write it as an actual system of equations. So this would be 4x minus 7y equals negative 3, 2x minus 3y equals 1. Yeah, you'll just write them as a system. Here, 2x minus b equals 6. 3y equals 9, x plus y equals 5. Okay. I'm going to go ahead and cut you loose. Oh, I already had this one EOE, so there's no point in doing this competition. What happens if you miss? Or it can upgrade to even. Sure. If you get it on your absolute first try, I'll bump it down to every other year. No, just Allie. You can try after her though. But hers is for all the marbles. Over the flag, off the wall. I'm left-handed. No. It's nothing to do with it.
I'm left-handed and I got the close.
No. Yes. You failed us. Alright, here we go. Tim, you gonna try this? I mean, Adam. No, it's literally impossible.
I don't think
If
it's
it wasn't for the phone, it wouldn't be
Oh, sorry. No, oh, you mean without banking it? Oh, yeah, you probably can't. What's the fun in that?
possible.
Now, if you kicked it, you are a soccer player. That'd be more fun.
Take it over to flagpole and then there.
Oh, I remember reading this. No.
So I only have to every other week.
No, no, every other week. Let's go. People at home are probably thinking, what is happening in